and time. If you have any conflict, comments in the Google Classroom, then I will give you another time. Same date, another time. And another reminder is you have an assignment number 2, which is the last date is 20th. Your final exam is on 18th. All right, so these are the dates you need to remember. Okay, so okay, and we also know that there will be more or less 7 or 8 questions in your final exam. I don't know yet because we will make a question and then it will go to the moderation committee and then let us see how many questions and how it's how they have modified or moderate. So more or less like 6, 7, 8 number of questions you might expect. The syllabus is all over the syllabus. Maybe most of the question, not maybe, maybe many of the questions will come from chapter number 5, 7, 12, and 13. 4, 5, 7, 12, and 13, which is the most of the question will come here from this chapters. Chapter number 1, 2, 3. These are all specifically, they are all very theoretical. You will have a question from chapter 1 to 3, of course. You cannot avoid any chapter, but number of questions, I'm saying number of questions, the possibility of number of questions may be more in chapter number 4, 5, 7, 10, and 12. Okay. And we have done practice so far, chapter 4, 5, 7. And I think we have also started chapter number 12 as well last class, right? Chapter 12, last class. Can you remember?
So
remember chapter what?
Risk type principles, 6 features.
Yeah, 6. Yes, correct. We have discussed 6 different types of principles or design architecture or design principles we have discussed. Let me share the screen. We are going to finish chapter number 12 today. We don't have that much time. Let us finish it fast. So last class we have discussed about this chapter number 12. Where is it? Yeah, chapter number 12, we have discussed about the MIPS processor, introduction of MIPS processor and the RISC processor we have discussed. Then we have discussed there are 6 design principles. These 6 design principles, very important question. These 6 design principles. First one is a simple operation, then register to register. Then we have addressing mode, large number of register, fixed length of the machine language, and also the Harvard architecture. These are the 6 features we have in the RISC architecture. Then we are going to discuss about the MIPS architecture, which is also very similar to the RISC design because it is the similar type of processor. So in this case, for the MIPS architecture, we are going to discuss about MIPS R2000. MIPS R2000. Remember the name. MIPS R2000 processor. This is very similar processor to our Intel 32-bit processor. The last time, chapter number 3, 4, what the processor we have discussed in those chapters 3, 4, 5, and 7. All those processors are generally Intel processor, and those are 32-bit processor. Most of them, actually all of them. Whenever we write code. Here we also do the similar thing. We also use the 32-bit processor, but the name of the 32-bit processor is MIPS R2000. Previously, we use Intel Pentium 32-bit processor, which is the 6 types of processor. In the RISC types of processor, we are going to discuss MIPS R2000 processor. That is the name, model name. All right. So these are the 32-bit processor, MIPS R2000. There is another type of processor which is the 64-bit processor, which is R4000. R4000. Just give me 1 minute. My internet, it says that I have 80% use, so let me just buy the internet. Just 1 minute. Somehow we don't have any current electricity, and the generator is also off, so it's a problem. That's 1 minute. There is fine. Fine. All right. So no problem. Okay. And so whenever we discuss about those Intel processor, 1 minute. Okay, 1 minute. Just a minute. Okay. All right. So let us discuss about this architecture, the MIPS architecture. The MIPS architecture. So in this MIPS architecture, we very similar to our previous Intel processor, chapter number 3, that we have discussed that how many register we have, and then what are the types of the register. Here is also the same. Previously, we have 3 types of register. Here we also have similar 3 types of register. First type is general purpose register. Second one is the program counter, in short PC, and another one is a special purpose register. So just remember these 3 names for the MIPS types of processor. MIPS R2000 processor. These types of processor generally used in your router, in your access point, the smaller devices, or the modems, those kind of devices. These MIPS processor. R2000 or R4000. So this processor has 3 different types of register. General purpose register, where we have 32 general purpose register. We have 1 program counter register, and we have 2 special purpose register. If you look at the image, it will be much more easier. This is 1 type. This is the general purpose register from 0 to 31. That means we have in total 32 bit general purpose register. All of the processor length are 32 bits. Okay, all of the registers length are 32 bits. Okay, so and the number of register is, look, general purpose, how many we have? 32. We have 1 program counter register, which is also 32 bit, and also 2 special types of register. It is called special purpose register. 32 bit as well. So in total, how many registers we have? Do you have MIPS R2000 processor? How many registers do you have in total?
35.
How? 32 plus 1
35.
plus 2. Yes, 35. So we have in total 35 32-bit register in MIPS R2000 processor. Can you remember how many register do you have in Intel processor? In chapter number 3 we have discussed how many types of data register we have. Intel 6 types of processor. Chapter number 3. How many data register we have? 4.
So 4.
4. EAX, EVX, ECX, and EDX, right? So we have 4 data register. After that, we have how many control register we have? 2, flag and EIP, sorry, instruction pointer, extended instruction pointer. That means 2 more. And we have 6 segment register as well, remember?
Yes, sir.
So how many we have? 4 plus 2 plus 6. And also there are 2. One is for the stack pointer, another one is for the array. So plus 2. So how many in total? 4 plus 2 plus 2, 8 and 6, 14 altogether. We have almost 14 registers. And also those 14 register in Pentium processor, they are not all 32-bit register, because the 6 segment register we have, they are 16-bit register. So if you think about the number of the register in Pentium processor, what we have discussed in chapter number 3, we have only 14 register. Here we have counted in the where it is the MIPS R2000, we have counted 35 32-bit registers. So that is the reason that we have said that we have large number of registers. That is the proof. Right? That is the proof that sorry, due to the phone call, it is disconnected. That's the problem. Anyway, let us start again. So we were discussing about the registers. So we know that there are 3 types of register: general purpose, where we have 32 general purpose register, one program counter. It is very similar to the EIC extended, so the EIP. I said EIC, EIP extended pointer register, same thing, and the special purpose register. So in these 2 special purpose register, we have high and low. So these 2, although they are saying that multiply and divide register, but the name is actually the special purpose register. Why they call it special purpose? Because they use it for the multiplication and division, right? These two register mainly uses for multiplication and division. Okay, whenever we do multiplication division in next chapter, we're going to see that how we're going to use it. Very simple. And this program counter register is, this program counter register stores the address, memory address of the next instruction needs to be executed. All right, so that is the uses of this program counter. And this 32-bit general purpose register, these are very similar to what we have used in the Pentium processor, like EAX, EBX, ECX, right? So many registers. Here is also we have 0, V0, V1, A0, A1, S0, S1, T0, T1. So different types of register. We have different name. And also there is a table, this table, where we can see that the name of the register and also uses, special uses of the register. Here in this 32-bit register, the first one and the last one, these two are reserved. Reserved means they use only for that. Look how they have written, intended uses, because they are expecting that we are going to use for this reason. Okay. So that's why they have said intended user. Fine? Except the first one and the last one. These two are reserved. These two are reserved for these two special reasons. One is we are using the first one, which is called 0 register, which we use to store the value 0. And the last one, the name is RA, this we use to store the address, return address, whenever you are using the procedure call. Do you remember the procedure call? What is it? Do you remember procedure call? Anyone? No one? Procedure call, I think we have discussed it in chapter number 2. Let me give you the clue. Flow of control. This is one type of flow of control. We have two types of flow of control. This is one type. Can you remember? No?
So I think it is that when the CPU is doing a process and in the middle, when the high priority task comes and the process done the high priority task, after that task we have to store the we have to store the address for
No. The procedure call is slightly different thing. Anyone else? Not close, but not correct answer. Try. Anyone can try. What is the procedure call? I told you, chapter number 2, this is one types of flow of control. Whenever we discuss about the processor, how the processor handle the hundreds of tasks. So there are two ways. It is called flow of control. One is procedure call. The other one is the jumping. No? We have discussed in the first term. That is a common problem, that is a common problem. And whenever we learn something in first term, you don't remember in the midterm. Whenever we discuss any topic in the midterm, you don't remember in the final. And after final exam, you forget everything. That is a problem. And that is a common problem whenever I ask you anything if in comprehensive Viva, seems like you have not heard it before, although we have discussed it so many times. And do you know what happened? It is actually happening in IBT like from the very beginning. Do you know what happened actually? All this, whenever, let's say you have graduated or you are in the comprehensive Viva, if any higher authority comes to the Viva, or after graduation, if you have any problem, this kind of problem that you don't remember, you don't have any skill, do you know who actually the higher authority than me? Who do you know who they blame? Us, teacher, faculty, higher authority, and everyone else. I mean, blame us that how did we teach the students? The student cannot answer this. Let's say, for example, this situation. I have discussed this procedure call so many times. We have done practice as well. We have done Viva. We have done so many discussions. I have done everything I could. Still, you cannot answer it. All right. Is it my fault? Yes, it is my fault in a way. 50% is my fault because I'm your course teacher. Every kind of your failure, every kind of your problem, I will be 50% responsible, or 50% responsible is you as well. Because if you don't study properly, if you're not attentive in the class, how can I make you attentive? Yes, I can encourage you. I can, by using all my teaching tools and techniques and everything, then I encourage you, I force you, I whatever, do that so that you can answer it. But I have done everything I can and I could. Still, if you cannot answer it, I'm not saying only you, all of the other students. Because there was an issue, this kind of issue we have faced last week. I'm not telling what was the issue, but these similar kind of issues. Students cannot answer a specific question. The student has some problem, academic problem, and the higher authority blame us, teachers, that you have not teach properly. That's why these students have this kind of failure. It is only me to blame. What do you think? For example, you don't know what is the procedure code. At least Mahbub Alam at least tried. 99% of others actually have maybe no idea, or confusion or hesitation that what is it.
Sir, procedure calls mean after.
No, I understand. No, I'm not asking now. I'm just saying that is it my fault? Is it entirely my fault?
No, sir.
No, sir.
No, sir.
Why everyone else is actually, first of all, is there anything happened to the student? First of all, they blame everyone else. Blame who? Faculty. You have a bad grade, or if you don't know anything, you don't have the required skill, who to blame? Faculty. You are facing problem, you are not getting job, you are not getting expected job. Who to blame first? Faculty. Yes, we accept that it is our fault, not entirely our fault. 50%, I told you that if you got a bad grade, 50% responsible is me, 50% is you. 50% me is because I couldn't teach you properly. But when someone says that the way you are teaching is wrong, that's why the students cannot answer this question. If someone says like this kind of blame, actually in that point I actually should resign from this faculty position. It is very sad. It is very sad that whenever someone says that the way you are teaching, it is wrong, you don't know how to teaching, it is your fault. That's why students having this problem. After doing everything, okay, I'm not saying that I'm the best teacher in the world. I am not, but at least I tried. At least I sincerely and honestly I tried to teach you something. All right, every one of our faculty tried the same way. Okay, maybe we are not the best teacher. Still, we have tried. But for your failure or for your problem, if the others blame entirely us, not the students or not any other parameters, they don't listen to any other parameters. I whenever they blame us, I try to defend us. Us means all our faculty that yes, we accept that it is our fault. Maybe we are not the best teacher, we are not a good teacher, we accept that. But this is not the only reason. There are so many other parameters. there are so many other reasons that a student actually cannot get the required skill or marks or job or feedback or whatever it is. But you cannot blame entirely to the faculty. It is very easy to blame others actually. Very easy. I can easily blame you as well. That it is your fault. That why don't you study? But I didn't do that. I take 50% responsibility and liability to me. Although I have tried everything. Although I have tried everything I have, but still I take 50% responsibility. 50% is you. I never say that it's entirely your problem. But on the other side, whenever I listen and when someone accused that it's entirely my fault, it's actually very demotivated. My teaching is my passion. I love it and I do it because I love it. I have so many other opportunities, very good opportunities I had. I didn't go there because teaching is my profession, that's why. I really have this problem whenever I listen to this kind of issues. Whenever I tried everything, still you were blaming me. Not you, I mean others. It is really upsetting to me. I was also upset whenever you were against us as well. And you also blame us, right? Against us. You were thinking that we are your opponents. So sad. Really sad. Just why I'm explaining this one, because just to clarify, there are our faculties. I don't know about the other department. I know very well my department's faculty. They are very sincerely tried their best. I told you, every one of the faculty, they are not the similar category. There is some difference between each other, but they have tried in their way. You should understand. And I suggest you, for the failure, for entire in my life, I told you several times, for my own failure, I don't blame anyone else. I don't blame. If I failed for some reason, if I didn't do it in successfully or something else, I blame myself for it because I had problem. Okay, sorry, I had problem. I didn't do it properly. I didn't blame, okay, I have this excuse. What will happen whenever you start blaming for your failure, you will never, ever, be successful, that's for sure. Because it will be a habit to blame others. Anyway, sorry for wasting your time. I'm just really a little bit upset because we have heard this one, last 1 week. That's why a little bit upset. A little bit upset. I think it is not good, but it's all right. It's all right. The problem is, whenever we do something wrong or we does something wrong, nobody actually give us any credit. Let's say, for example, whenever a student are very successful in their life, right? Is there anyone, any university authority or the students or anyone else come to us and say that thank you very much for your suggestion, for your guidance, for your teaching, for your love, for your caring? Is there anyone? Very few. Very, very few in my entire teaching life. 1, 2, 3, 4, 5 maximum. And the thing is, I don't expect. The faculties, the teachers, they don't expect, never expect that, okay, I'm giving you some opportunity, I'm guiding you, in return, I want something. Never. Never, ever. We don't expect anything. Nothing. If you are successful, if I just know the news that you are successful, you are having a very good life, that is our reward. Nothing else. You also don't need that someone will come to us and say, thank you, sir. We don't need that. We don't expect that. We just need to know that, yes, you are fine. You are very good in your life. That's it. That is our reward. Nothing else. But the sad thing is, whenever you have something wrong, first to blame is us. If the student cannot get a good job, if the student cannot answer the question, if the student has a bad grade, if the student has a problem in their life, who to blame first? Teacher. Why I'm saying this? Just to understand the difference. these two scenarios. Whenever someone is successful, doesn't matter to the teacher, because it is the student credit. Of course, it is the student credit. 100% credit is the student, no problem. But when in the same opposite scenario, when the student facing some problem, who to blame? 100% blame is the faculty. That is my point. That it is really not right to me. Right. So that is actually my main issue, and it is actually a common issue. It is issue from the student, from the others, from the authority, from everyone else. It is a bad culture in our country. I'm not saying about our university, it's the same about the other as well. It is our bad culture of our country. Anyway, no problem. No complaint. It's fine. No problem. Anyway, so these are our 3 registers. So these are the responsibilities. I'm really sorry I wasted your 10, 15 minutes. Anyway, so whenever we write the register name, now we know that we have to write the register name with $sign. We need to write $sign. Unlike the previous Intel register, Intel Pentium, they don't need to write the $sign. But here we need to write the $sign before the register name. So that is the way we write. Fine. And the addressing mode also, if you remember that in the Pentium processor, that is the 6 types of processor, the addressing mode are very complex. We have register addressing mode, immediate addressing mode. There are 2 types of memory addressing mode. There are some other types of addressing mode as well. So those are complex. But here, sorry, it's my daughter. Stupid. No. I was busy. Sorry. No. No. I don't want to. See. That's good. No. Sorry. No. 1 minute, please. No.
So baby is looking so cute, sir.
Sorry, guys. Sorry, my daughter. Yeah. So, addressing mode, as I said, that Intel processor have very complex addressing mode, but here we have very simple addressing mode. Here, the MIPS processor is using, most of the time we are using the register, right? So we are using register addressing mode. And here we're using also another types, which it allows. Another type is register immediate addressing mode. That means you can use the register as well as the immediate value in the code. We will see in the chapter number 13 whenever we write the code. So what is the main point here is the addressing mode here is very simple, and it is register-based addressing mode, because most of the tasks we have done or we do in the register, but there is some special load and store architecture. Only that they're using the main memory. Other than that, all other using the register. Right? So that is the register, that is the addressing mode. Last part we are going to see is the memory use. This is the last topic, then we'll finish our class.
Sir,
So the memory use, yeah.
sir, can I leave, sir? Actually, I joined mobile app development course, sir, and my class started from the 2 p.m., sir.
What is it?
Sir, a mobile app development course, sir, from the ICT department, and this class started from today 2 p.m., sir. Can I leave now?
From ICT. Yeah, okay. write your ID.
Yes, sir. Sure, sir. Thank you, sir.
Okay. So the memory use, that is the last thing we're going to discuss. If you remember about the Intel processor, every time we are talking about the Intel processor, because if we can compare these two, that CISC and RISC types of processor, yeah, I think it is much more easier to understand. That's why every time I'm talking about the CISC and RISC processor. If you think about the CISC processor, the memory use, we have so difficult memory architecture, right? The protected mode memory architecture, the another one is the real mode architecture, and the third one is the hybrid or mixed mode architecture. So difficult, very difficult and complex one. Here we have very very simple one. Here we divide our data in three, or we divide our memory in three different parts. Okay, three different parts. One is the code, which we call them text. Then we have data, and then we have space for the stack operation. So three parts we have this. Divided. Text. Next part, that is the code part actually, in the data. And data has two parts: static area and the dynamic area. Static area means this is fixed; it will never change. But dynamic area, the memory space of dynamic area of the data segment will change, depends on the memory allocation we do or we did by writing the code. So whenever you write the code for the large memory location, this will increase. And the other one is the stack operation. The stack operation is very similar. What happened? Can you hear me?
Yes, sir. You can.
Yes, sir.
My UPS is also gone. And my laptop battery is now 28%. Anyway, I don't know what happened in sector 10. Everything, anyway. Yes, just finished. So the third one, it is too dark maybe. Anyway, the third one is the stack segment. Let me just switch off. The stack segment. This stack segment, we know that stack always started from the top and then coming towards the memory location. Right, so it starts from the top of the memory and down towards the lower part of the memory. All right, so this we have three different options: text or code segment, data segment. All right, data segment. We have two data segments. We have static and dynamic data segment, and another one is the stack segment. All right, just remember, stack started from top of the memory. Top of the memory. All right, so that's how we can distribute. By the way, we have another reserved area in the lower part of the memory. Okay, in the lower part of the memory, we have the reserved area. Other than that, we have these three different segments, and that's how we can use our memory by using the MIPS processor. Fine, that is the end of this chapter as well. So let me just very quickly just say that what is in this chapter number 12. We have started with what is the MIPS processor, where we use it, the introduction, why we need the RISC processor, what is the differences, which we already discussed in chapter number 1 as well. We still have discussed here as well in chapter number 12 about the MIPS processor. And then we have discussed about 6 different design principles. 6 design principles. We have discussed very important question. And then after that, we have discussed about our MIPS architecture, where we have discussed about the register. We have discussed about our addressing mode. And we have also discussed about our memory uses as well. Okay, so that's what we have discussed so far. Fine. So that is the chapter number 12. Right. Please make sure you read it from the book as well. There may be one video related to this. You can watch the video as well, but I prefer that you read from the book. Right? If you read it from the book, it is much, much better. Okay. Any question? before we finish?
No, sir.
Fine, okay, so let me give you the attendance. So many disruption. At the moment, I don't have any electricity. I'm using my laptop. Thanks God, I have the charge in my laptop. And no data, I'm using the mobile data as well. Last 2 or 3 hours, there is no electricity here. Anyway, let me give you the attendance very quickly. You are section C, there's 13, 10. All right, CSC 197 section C. Section C, yes, correct. Shakil Ahmed is fine. Mominur
Yes,
Rahman. Mominur Rahman, fine. Saidul Islam. Moinul Islam.
Yes.
Emil Choker.
Yes, sir.
Shariar Haq.
Yes, sir.
Arifur Hakrani. Mukit Hassan Jim.
Yes, sir.
Mukitul Islam. Shabujur Rahman.
Yes, sir.
Ikon Kumar Das.
Present, sir.
Hamid Hassan.
Present, please.
Ubel Babu.
Yes, sir.
Rizwan Ahmed.
Present, sir.
Jannat Naim.
Yes, sir.
Imtiaz Tasnim.
Yes, sir.
Shahid Ahmed.
Present, sir.
Shadia Akhtar.
Yes, sir.
Afia Siddiqa.
Yes, sir.
Rahul Devnath.
Yes, sir. Yes, sir.
Abdul Sabur. Ronald Kabir. Rubai Talam.
Yes, sir.
Amiul Rudro. Lamia Akhtar. Sumaya Islam. Bir Hussain. Fahim bin Shohid. Muhammad Mahbub Alam.
Yes, sir.
Nurak Tamim.
So she was there.
All right, Nushin Tasnim.
Yes, sir.
Yamiul Islam. Shahriar Shimon. Tushar Gup. Ashik Rahman. And Janatul Firdaus.
Yes, sir.
Tahmina Nasrin.
Yes, sir.
Tahmidur Rahman.
Sir, he got disconnected.
All right, Rukia Jannat.
Yes, sir.
Rakibul Hassan.
Yes, sir.
Sabia Parvin.
Yes, sir.
Nidhi Hassan. Alamin Akash. Abdul Salam.
Yes, sir.
Anyone else? Anyone else? No. 14%. Anyway, thank you very much, all of you. See you in the next class, right? Allah Hafiz.
Assalamualaikum, sir.
Walaikum assalam. Allah Hafiz.